If you have two structures and want to compare them, provided that both of them are in default setting of a space group, you can go to the Bilbao Crystallographic Server in a web browser and come to structure utilities COMPSTRU. The program will ask you to input the two structures, so we will input the low temperature form of Theoria 2 in the default setting PMC21 that we obtain by applying setStru program, and we will get the high temperature form of Theoria 1 that we obtained in also PMC21 space group using turnstru program. The two of them are in PMC21, which is the default setting for the space group 26. Comparison will start from the cell parameters and then go to atomic positions. So we need to give tolerances values. In this case, the tolerance by default work. So we will hit show, and here is the description of structure number 1. This is the low temperature form of Theoria, and this is the description of structure number 2, the high temperature form of Theoria, which is actually PNMA. This is a polar space group, and in general polar space groups can have different coordinates depending on the choice of the origin. So a grid is asked to be chosen. This is the maximum shift that will be searched for. So we continue, and the program will calculate how to correlate the two input structures. After about 50 seconds, we get the description of structure number 1, which is low temperature Theoria, as we input, and the description of structure number 2 as we input. This is a high temperature form of Theoria with a change of space group, and this is the description of structure number 2, the high temperature form, in the most similar configuration of the low temperature one. As usual, you can save the description of structure 2 in the most similar configuration of structure 1 in a zip file. So then you can use any software you want to visualize and compare the two models. Here we have the transformation matrix for making the structure 2 as similar as possible to structure 1. There is only a translation that needs to be applied because both structures were represented in the default setting of a space group. This is the matching of the coordinates of atoms in first model and the most similar configuration of the second model. These are the differences in atomic coordinates, and then there is a calculation of a lattice distortion, which is the S term, and also maximum deviation of atomic positions. And if you check this number here, this corresponds to some hydrogen atoms in the structure. Then there is also a calculation of the average atom shift and the similarity between the two structures. The measures of similarity are the same that are included in the program structure relations that allow to compare two structures that don't have the same space group. And you can also go into the right part where there is a Jmol representation of the structure number 1, structure number 2, and the structure number 2 in the most similar configuration of structure number 1, and you can compare the descriptions, the two of them, and here you see the overlap of the two models, where you can clearly see that they are very similar but not identical because there is a phase transition which changes position of the atom.